Hey everyone, welcome back to Deep Chemistry, where we make chemistry fun and full of meaning. Today we are diving into one of the most important topics in all of chemistry, the mole concept. This concept connects the microscopic world of atoms and molecules to the real world we can measure in grams, liters, and numbers. So let's begin our journey into understanding what a mole really is and why it's such a powerful idea in chemistry. Alright, imagine this. You are baking cookies and you need to know how many ingredients to add. In the same way, in chemistry, we need to know how much of each substance takes part in a reaction. But the problem is, atoms and molecules are super tiny. We can't count them one by one. So chemists invented a smart way to count them using a special unit, the mole. It helps us link the world of tiny particles to the quantities we can measure in the lab. So, what exactly is a mole? Well, a mole is just a counting unit, just like we say 1 dozen means 12 things. Similarly, 1 mole means 6.022 into 10 to the power 23 particles. This number is called Avogadro's number. It can represent atoms, molecules, ions, or even electrons, depending on what we are talking about. For example, 1 mole of oxygen atoms equals 6.022 into 10 to the power 23 oxygen atoms. 1 mole of water molecules equals 6.022 into 10 to the power 23 water molecules. So, in short, 1 mole equals 6.022 into 10 to the power 23 entities. Now let's see how mass is related to moles. Every substance has a molar mass, which is the mass of 1 mole of that substance. It's simply the atomic or molecular mass expressed in grams. We use this simple formula: number of moles equals given mass upon molar mass. For example, if we have 36 grams of water and we know that water's molar mass is 18 grams per mole, then number of moles equals 36 upon 18, that are equal to 2 moles. So, in 36 grams of water, we have 2 moles, or in other words, 2 into 6.022 into 10 to the power 23 molecules. Next, let's connect moles with number of particles directly. We use this formula where small n is moles, capital N is number of particles, and Na is Avogadro's number. Let's say we have 3 moles of carbon dioxide. Then total number of molecules will be 3 into 6.022 into 10 to the power 23, that is equal to 1.806 into 10 to the power 24 molecules. That's a huge number. Now you see why chemists prefer moles instead of counting molecules one by one. Here's another cool part. Gases have a direct relationship between volume and moles. At STP, which means standard temperature pressure, that is 0 degrees Celsius and 1 atmosphere pressure, 1 mole of any gas occupies 22.4 liters. So if we have half a mole of oxygen gas, the volume will be 0.5 into 22.4, that is equal to 11.2 liters. This makes gas calculations super easy in stoichiometry. Let's summarize all the relationships in one simple table. You can remember this formula very easily. You can move between mass, moles, volume, and number of particles using these three golden relations. We just discussed that at STP, 1 mole of gas equals 22.4 liters. So 2 moles equals 44.8 liters. 3 moles equals 67.2 liters, and so on. It's that simple. If you ever forget, just think of it like 1 mole of gas always breathes in 22.4 liters of space at STP. Let's take a quick example. Find moles of carbon dioxide in 11.2 liters. Then small n will be equal to 11.2 upon 22.4, that is equal to 0.5 moles. Now here's where the real fun begins. Chemical reactions. Moles helps us understand how much of each reactant reacts and how much product forms. Take this example. From this, we can say 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water. So if you start with 4 moles of hydrogen, you will need 2 moles of oxygen and you will get 4 moles of water. Simple ratios, simple chemistry, all thanks to mole concept. You might be thinking, why do we use the mole? Why not just count the particles? Because counting individual atoms is impossible. They are too tiny and too many. The mole gives us practical way to connect measurable quantities like mass and volume to atomic world. And that famous number 6.022 into 10 to the power 23 isn't random. It's number of atoms present in exactly 12 grams of carbon 12. That's how the mole was defined. This concept is heart of all quantitative chemistry. Without it, you can't predict how much product forms or how much reactant you need. Industries use it for preparing solutions, controlling purity, and designing reactions. It's used in labs, environmental studies, and even in biochemistry to calculate the number of molecules in living systems. In short, wherever there's chemistry, the mole concept is there. Alright, before we wrap up, here are some quick questions to test your understanding. Why is mole called chemist dozen? How many atoms are there in 2 moles of oxygen? If 1 mole of propane burns, how many moles of carbon dioxide are produced? If 11.2 liters of gas weighs 16 grams at STP, what's its molar mass? Which has more atoms, 1 mole of sodium or 1 mole of chlorine gas? Try to solve this or check my conceptual question series for better understanding. Let's quickly revise the key formula once again. All these relationships help connect microscopic and macroscopic quantities beautifully, and that's the magic of mole concept. It's like the translator between atoms and grams. So that's all for today's lesson on the mole concept. I hope this session made the topic crystal clear for you. If you enjoyed learning with me and want more easy chemistry lessons, please don't forget to like this video, subscribe to Deep Chemistry, and share it with your friends who are learning chemistry. Thanks for watching, and remember, chemistry isn't hard when it's taught with heart. See you in the next video. Till then, keep exploring chemistry deeply with Deep Chemistry.